Laws of motion. In this video, we are going to discuss about the second law of motion. Before we have a look at the statement and its meaning, first let us clear the concept of momentum. What is momentum? Momentum of a body is defined as the product of mass of the object and its velocity. So mathematically, momentum denoted by small p equals to mv, mass into velocity. If an object is moving and has mass, then it has momentum. So something that has large mass has large momentum, or something that is small but is moving very fast, that also has large momentum. For example, a bus has larger mass. Even if it moves with low velocity, it will still have large momentum. Or a bullet fired from a gun, it has a small mass but the velocity is very high, hence it also has larger momentum. So can you imagine the momentum of a bus moving with the velocity of the bullet? I'd say it will be very high. So now the statement for Newton's second law. Force is measured as the rate at which momentum is poured on a body. So mathematically it is represented as force equals to dp by dt, rate of change of momentum. So that will be mass into dv by dt, mass of the given object is constant, m into dv by dt, rate of change of velocity is nothing but acceleration, hence force equals to mass into acceleration. This is the mathematical representation of Newton's second law. Now, pouring momentum. What do you actually understand by pouring momentum? Let us take an example to understand that term. A ball of 2 kg moving at 2 meters per second hits a door normally and rebounds normally at 1 meter per second. What is the force on the door if it is in contact with the door for 0.1 second? How many such balls will be required to be thrown simultaneously to knock the door if the door can withstand a maximum force of 600 Newton? Okay, so let us imagine the scenario. A ball and a door. The ball hits the door and rebounds from the door at given speeds. So the ball's initial momentum will be mass of the ball into its initial velocity, that will be 4 kg meter per second. Its final momentum will be mass as it is and its final velocity. Final velocity will be -1 because it rebounds in the opposite direction. Hence that will be -2 kg meter per second. Hence the change in ball's momentum will be final minus initial, that will be -2 -4, that is -6 kg meter per second. It means that the ball poured 6 kg meter per second momentum on the door, which was exchanged in 0.1 seconds. So now we have the momentum poured and given time duration, so the force can be calculated as change in momentum upon change in time. Taking only the magnitude, we have 6 upon 0.1, that will be 60 Newton. It simply means that a single ball hit the door with a force of 60 Newton. Then if n such balls hit the door simultaneously with a force of 60 n Newton, then we can knock off the door. So to knock off the door, this value of 60 n should be greater than 600 as given in the question. So it simply means n should be greater than 600 by 60, that is nothing but n should be greater than 10, which simply means that we require at least 11 such balls to be thrown simultaneously at the door to knock it off. So that is all you need to know about Newton's second law. Practice more such numericals so you develop an understanding regarding change in momentum and force. May the force be with you. And don't forget to subscribe.